We've basically gotten the core functionality of our int vector class working. But before we move on, there is one more thing I want to add, one more detail. Maybe it's sort of a syntactic convenience, but it's sort of an important one. So far, in the previous videos about the int vector class, we have been creating our vectors with a call to the default constructor, and then using pushback to add elements, which is fine, and it works, and the vector has all the functionality we want, but we're used to, going back to like the first week of the semester, we're used to being able to construct a vector and provide the initial values of the vector, some predefined sequence, in the call to the constructor, which is great if we know our vector is going to contain a bunch of elements initially to avoid some tedious sequence of pushback operations. So although it is a convenience, I think it's worth exploring exactly how that works, because it gives us another opportunity to come back to how different constructors, or how writing a set of different constructors for a class can be helpful. So my goal for this video is to uncomment this code and then make all 4 of these lines compile. And the print vector function is the same one we've been using, so really I just want these 2 constructor calls to work. And so I guess in the spirit of wishful thinking, we'll just hope they already do, and we can have a nice short video. But they don't. And we shouldn't be too surprised by that, because over the past few videos, we have written 2 constructors for our int vector class, but neither of them make any sense for these 2 arguments. And the compiler tells us that. It says, sorry, can't do it. And it says no matching function for call to int vector : int vector, which is it looking inside the int vector class for something called int vector, that is to say a constructor. It then shows its work. It says, well, I tried this one, which we can see is the copy constructor that we wrote last time, and this one didn't work because you're passing in 2 ints, not another int vector. I want, you gave me 2 arguments, this expects 1, and then also it doesn't point out, to be polite, it doesn't point out that this is also not, the arguments you provided could also not be converted to this. And then it says, well, there's also the default constructor, but obviously that doesn't work either. So what do? I want my vectors to be, I want to be able to construct my vectors by providing a bunch of elements initially. So I'm going to begin by approaching this in a sort of flippant way, which is, oh, well, you want to make a vector with 2 ints already provided. Sure, I can do that. I can write as many constructors as I want. So why not just write a constructor that takes my first 2 elements? So I'll take int x, int y, and I'll add those to my vector. So I'll begin by delegating to the default constructor to get the vector all set up for use. So that means that as of line number 23, the vector has been constructed with a size of 0, capacity of 10, and a storage array that's already prepared. So that's what I get by delegating the initial construction to my default constructor. So I'll add my first 2 elements by just calling pushback on the 2 elements that you provided. All right, and I will put a little note here. So I'll say 2 argument constructor, just to remind ourselves which constructor has been called. All right, and actually, now that I think about it, that's going to be, put a hyphen there. Okay, so we'll see if that compiles now. And the compiler goes looking for a constructor to call back down in main, and it says, well, I've got a constructor that takes nothing, the default constructor. I've got a constructor that takes an int vector, that's the copy constructor, but hey, now there's a constructor that takes 2 ints. That looks like the one that I will call. So the compiler, as usual, can resolve the different overloaded constructors using the context. And I run the program, it says, yep, I'm calling the 2 argument constructor there, and then it prints out the 2 elements of the vector. That sounds good. All right, so I've got that working. But on the other hand, I say, great, so now I can initialize vectors to have a bunch of elements. Let's try this one. I'm sure this'll work, right? And it doesn't. And the compiler gives the same complaint. Sorry, I don't have a constructor for you. I've tried the following 3 things. Can't call the copy constructor. You gave me 7 arguments. It wants 1. I can't call the 2 argument constructor because that takes 2 arguments and you gave me 7. Okay, can't call the default constructor for sort of obvious reasons. So what do? Well, we could keep going on the same track and we could make a constructor that takes 7 arguments, but I hope you can see how that's going to be futile. So if I can't define a different constructor for each number of arguments you could provide. You could provide 1 or 2 or 7 or 100, and I can't, read your mind in advance. I want my int vector class to take as many arguments as you provide with some restrictions. So for example, in this case, you're providing a bunch of ints. If you give me strings, I don't know what to do with them. But if you give me a sequence of ints of any length, 1 or 2 or 7 or 100, I should be able to work with them. I shouldn't need to write a million or an infinite number of different constructors. And also, we know that the regular vector type in the library can do this. Std vector can initialize itself based on any number of elements. And because the language holds nothing back, we should have that option as well. So it is actually possible to write classes that where you can construct them with any sequence of any number of things of any types in any order, that requires some deep magic that we're not going to get into in this course. I could actually make it so you could construct my int vector class with a huge list of things of all sorts of weird types, as long as you could find some way of working with them. What I want for today is a great deal more humble than that. So that topic of how do I write constructors that take an arbitrary number of arguments of any type, that's more complicated. But what I want now is something pretty humble. I want to be able to take a sequence of ints, just ints, of any length and initialize my vector to that. That's all that makes sense for a vector. And I know that I can't just go around writing constructors for every possible number of arguments. That would make no sense. And the language actually gives us an option there. The language allows us to define a special constructor that takes a sequence of things of a particular type. And then it gives you the sequence in a nice form that you can work with like you're used to working with sequences. This is also neat because it's an example of a case where the language specification and the standard library are sort of tangled up in each other. Because I can write a constructor that takes as its argument a sequence of initial elements. So I'll begin writing that now. Int vector, it takes a sequence of initial elements of, well, wait a minute. If it takes it as an argument, what's its type? We'll get to that in a second. It's going to construct, just like before, we'll call the default constructor first to set the vector up for its initial use. And then I'm going to iterate over my initial elements because it's a sequence. So I have to go through all of them. So I'll say for every initial element x. Because I think we can agree that a for each loop is a very natural, fundamental thing we expect a sequence to have. For every element that I get, I will add it to the current vector. That's all there is to it. But the question is, how does the compiler provide this to us? We get some sort of a hint, I guess, if we look at the error it gave us earlier. It says, I'm looking for a constructor that takes as its argument a brace-enclosed initializer list. It doesn't give us an actual name of an argument like it does here, like int or int vector ampersand. It just says brace-enclosed initializer list. But that is a hint. The compiler wants to call one constructor that takes apparently one thing, this initializer list, as its argument. But if I want to write a constructor, I have to actually put a type here. I have to give the argument a type. And the language worked around this by defining a very special standard collection. This is actually a standard collection just like vector or list, but a great deal more restricted. Std Initializer List. It is part of the standard library, at least notionally. It's in the header called utility, which is just the gift that keeps on giving in this course. Std Initializer List is a special type that exists sort of as an interface between the lower level language feature of whatever a brace enclosed initializer list is and the practical demand that you have some type for your argument. If you define a constructor that takes Std Initializer List as its argument, notice how I'm saying initializer list of int, so it only will work with sequences of ints. If you do that, then anytime you provide a sequence of ints as a constructor call in this for your type, whether it's 1 int or 2 ints or 7 ints, the compiler will package all of those up into something of this type and then call this constructor. For the sake of seeing the distinction, let's put in a print statement. So we'll call this the initializer list constructor. And Std Initializer List is actually a standard collection, just like vector or list. But it is not a vector, and it is not an std list. It is instead the most basic, bare bones abstraction of a sequence you can think of. What can you do with an initializer list? It is read only. You may not add elements. That makes no sense. Instead, you can iterate over it and ask it its size. That is it. It is just the bare minimum to be a sequence of elements. That's all you need. Just the bare minimum to iterate over it and then grab each element one at a time. And if we can iterate over something in the standard library, we can also use a for each loop. And we're going to see in the next couple of videos how we could write that functionality for our vector type. But until then, we need to get our initializer list constructor working. So here I have my initializer list constructor. And we'll go back down to main. And we'll see we're constructing two vectors. This one we were constructing before with that 2-argument constructor, which takes int x and int y. This one, there was no constructor to do it. Let's see what happens if I try to compile now. All right, so it does compile. I try running it, and we can see it was able to successfully construct both vectors with whatever elements you gave it. So I gave it 7 here, but suppose we were only to give it 6. No matter how many elements I provide, if they're all ints, they can all be packaged into an initializer list of int. And the compiler knows how to do that, and it knows which constructor to call. And as a result, I can now construct my vector objects using arbitrary sequences. We're not quite done with the topic. There was an interesting question that just showed up there, which is, hey, wait a second. Didn't I write a special constructor to take the 2-argument initializer? And yet, when I provide 2 arguments, it always uses the initializer list constructor. This is actually a sort of odd feature of the language. So when initializer lists were introduced, which would be C++ 11, the same time uniform initialization was introduced, it was decided that if the class defines an initializer list constructor that works, so for example, the class here does have an initializer list constructor that takes an initializer list of ints. If an initializer list constructor is viable, it is always the one that is chosen. If there are multiple candidates, so in this case, there are 2 constructors that might work. The one that takes, I'll scroll down to show it off. This constructor might work if I pass in 2 ints, and this constructor might work because 2 ints is an initializer list of ints. The language has decided that when you use uniform initialization, so the curly brackets, when you use uniform initialization, it'll always prefer the initializer list constructor. That is always the one that is chosen. Okay, so that's why if in main, when I construct both v1 and v2, it always uses the initializer list constructor. So then the question is, wait a minute, what if you really want to use that 2-argument constructor? What if you really want that one to be chosen instead? The language does give you an option, and it's an old-style notation that we otherwise should avoid using. So I encourage you to only use this notation if you are in this situation. If the compiler is preferring initializer list constructors and you don't want them. Do not otherwise use this notation. There are all sorts of reasons this notation was otherwise deprecated. It is a notation, instead of being called uniform initialization, which we should think of as the standard initialization syntax that we should always use. There's also what's called direct initialization, and that's where you use round brackets. When you use curly brackets, like we do down here, the compiler will first look for an initializer list constructor that would work with the arguments you provided. When you use direct initialization, the compiler won't look for an initializer list constructor at all. It'll only look for constructors that take this exact number of arguments. So when you use round brackets, you are saying, I want to call the constructor. Notice how because I'm using round brackets, it looks a lot more like a real function call. I want to call the constructor that takes 2 ints as their arguments. That is it. I don't want any funny business. I don't want any generalizations being done. Uniform initialization, so curly brackets, includes a bunch of other logic to make the construction more convenient. For example, using initializer lists. So here, because there is a 2-operand constructor, a 2-argument constructor, the direct initialization with round brackets would choose that. And if I use round brackets down here, the compiler would, well, we'll see what it does. So if I use round brackets on line 135, it says, I'm sorry, there is no constructor that takes exactly 7 ints. You see, notice how here it says int. Oh, sorry, I guess it's 6 now because I changed it. There is no constructor that takes 6 ints. There's a copy constructor, an initializer list constructor, the 2-operand constructor, and the default, and that's it. And so direct initialization or direct construction is something you really should avoid using unless you need it. But in cases where uniform initialization has the wrong logic, so in cases where you want that 2-argument constructor to be called, there is an option. There's a way to work around the, I think, more convenient logic of the curly bracket uniform initialization. However, for our purposes, we're never going to need that. We're always going to write classes that are designed to work with uniform initialization syntax, and I think in this case, the initializer list constructor did what we wanted, so why would we want to use the other one instead? So when you write an initializer list constructor, you are telling the compiler no matter how many arguments get passed in, if they're of a type that works, for example, initializer list of int, call the initializer list constructor. And as a result, you can now construct vectors by providing however many elements you want at the time of construction.